Welcome back to the Introduction to Animation Nodes tutorial series. If you came here directly, you might want to start at the beginning. All the info and links are in the video description below. In this video, we will use the Object Instancer. So let's hit Shift A, Object Instancer. It's right at the bottom of this menu. The Object Instancer creates or takes an object, an existing object in your scene, whatever you put in here, and then creates copies of it. So let's just hit the eyedropper, get the cube in here. We want 10 instances. Now over here you can see Animation Nodes created a collection called Animation Nodes Object Container. And there's 10 cubes in there. 10 instances of my original cube. Why can't I see them? Because they're all at the same location. It just takes that cube and creates 10 new instances of it. And the output is, you can see it's a little bit transparent and it's black. It's a list of objects. Let's see if it's a list of objects. Plug in a viewer. Yes, it's 10. Length is 10. It's a list of 10 objects. Now, what can we do with that? Well, we could try and maybe put them in random locations. So we need 10 random locations. A location in 3D space is a vector, x, y, z. So here we have a node that gives us a random vector. It gives us a single random vector, but it has this feature here. Every time you see this little button here, you can switch this on and then it turns this node into basically a generator of a list of random vectors in this case. And as soon as you switch that on, you get a new option here, which is count. And how many do we want? 10, right? So we have 10 cubes. So we want 10 random vectors. Now what can we do with those? Let's go Shift A, transform output. And the transform output node can take a single object, but it can also take a list of objects. Some nodes in Animation Nodes can do both. Just like this one can either create a single vector or a list of vectors. Some nodes can take a single object or a list of objects, and it actually changes the behavior of the node depending on what you plug in here. Let me demonstrate. So if I switch on XYZ because I want to change the location, and I plug in, let's say I just plug in a single object. Maybe this isn't even available anymore. Maybe a single cube. Now I can change this cube's location to a new location. But if I plug in a list of objects, now this becomes transparent. Now I have to plug in a list of locations, right? So 10 objects transform the output to 10 new locations. As soon as I plug that in, our 10 cubes are at random locations now. The scale here, the random vector has a scale feature. And if I change that, you can see I'm spreading them out further, but they're basically always in the same direction. When you think of it as a vector starting at the world origin, going out to this one now, the scale is just the length of that vector. If I want different vectors, I have to change the seed. That's just a random seed for the random number generator. So now I have 10 cubes. Actually, I have 11 because I have my original one in here too. But I have those 10 cubes at random locations. And because I'm using the object transform output, I'm actually changing the location. These are real instances. There is no magic going on here. Animation Nodes simply created 10 new objects for me and then changed the location. And when you select one, you can see it's at that location and this one is at this location. Okay, now let's go back to my first cube. And maybe I just want to add a little bit of a bevel. So now my starting cube has a bevel on it, but the other cubes don't. Maybe because it didn't get executed. Let's execute the node tree. Nope, those nodes don't get the bevel. Why is that? Because it instances the mesh data, but it doesn't copy the modifiers over. You can do that by enabling the copy full object. When you hover over that, it says enable this to copy modifiers, constraints, and so on from the source object. That's what I want. And now all my copies in here also have the same bevel modifier on it. And if I go in here and I change the bevel, maybe make it bigger, now actually they don't update because the node tree doesn't get updated. But if I maybe change the frame number, no, doesn't work either. Sometimes you have to disable and enable the copy full object to let animation nodes know that it has to copy over new modifiers to all of these objects. Okay, so now we have 10 objects. We instanced our original cube 10 times, and we transformed these 10 cubes to random locations. What if we wanted to transform them to something like a grid, like an array modifier? I'm sure you're familiar with the array modifier in here. So let me delete all of that. Let's delete those 10 cubes. So we're back to our original cube. Oh, the instancer is still in here. So now we have 11 cubes all in the same location. Let's figure out how we could simulate an array modifier without an array modifier. So we need a node that creates locations for us sort of in a maybe 1, 2 or 3 dimensional pattern. And there is a node that does that, which is the matrix distribute node. So what does that do? It gives us a list of matrices. You can see it's transparent, and it also says matrices, plural, list of matrices on a grid. There's also linear, circle, mesh, spiral. Okay. Then we have step or size. And then it gives us something XYZ divisions, width, length, height. Okay, maybe we should just visualize this. So let's plug in a 3D viewer. It not only gives us matrices, but it also gives us the vectors of these matrices. So the location information, we can plug that in here, make it bigger. Okay, so we have a 2-dimensional matrix. It's divided 3 times on the X, 3 times on the Y. It's 5 units wide and 5 units deep, basically. If I switch that over to step, then we get X divisions and X distance. So let's say we want 10 by 10, and the distance between each one is now 1. You can see if I go back to size, it just means it puts 10 X divisions within 5 meters of width. Okay, so now we have a 10 by 10 grid. It's kind of narrow, so let's increase the X and the Y. So let's do 3 and 3 for the X and the Y. And now this is just a 3D viewer. Let's put our objects at those locations. So how many do we need? Well, we need 100, we know that. But I don't want to put in 100 in here, because what if I want to change these? I know that I want 100 because this list here has 100 vectors. So how about I take a list, get length node, take this list. This now gives me, let's check it out, 100, and I want 100 instances. Now I have 100 cubes in here. Holy moly. Okay, and now I want to transform those 100 cubes to their location. Can do that within object. I could use a transform output for the location, 100 objects to these vectors, and then I have 100 cubes. So this is basically an array modifier on top of an array modifier, but all done in animation nodes. 100 by 100 cubes, plus of course my original cube in the middle, which I can now hide. I don't need it anymore, unless of course I want to go in and change it. So that will be that setup to distribute objects. Now we have 2 dimensions. What if I add them 3 C divisions with a distance of something? Now I have an array in all 3 axes basically. Okay, now you can already see, yes, this is basically the same as adding 3 array modifiers to my cube. But inside of animation nodes now, I'm much more flexible because I could even add some more stuff in here. Like, for example, vectors and vector calculations. Maybe do a vector offset, plug in a vector here, and offset everything on the x-axis or the y-axis. I'm offsetting all of the 100 vectors with one node. And this cool offset vector node even has a fall off. So what if I set this to 1? Or maybe I set it just to, maybe do x and y 0, and then for the c I do 1. And it takes a fall off. So we could take in a fall off, maybe a random fall off. Plug that in here. Oh, now we have some random variation, something that is increasingly harder to do with the array modifier. You can think of this fall off basically as a value between 0 and 1. So I'm adding this offset, which again is a vector, to this list of vectors with a certain factor. But the fall off is not just a value between 0 and 1, it also works with lists of objects. So it can assign a different fall off to each of the incoming vectors. And that's why this actually gives us a nice looking random change in the C direction here. You know, we're just changing the C value. Of course, we could also change the X randomly, or we can change the seed to give us different numbers. Okay. There's also different types of fall off nodes. A cool one is the object, where is it? The object controller. So you can take an object and use that as the fall off controller for a fall off. And we will look at that in the next episode. I hope you enjoyed this video. If you have any questions, write a comment below. Don't forget to like and subscribe. I really appreciate it. See you in the next episode.